And now we can go ahead and source this in. So let's make some room. We will do a merge with our density. So again, here we have the density, and let's get rid of the display for the geometry. We no longer need this. We are going to merge the density with our velocity field, and in the Pyro Solver, let's go to sourcing, and we have our density here. We are not going to use temperature or flame, but we are going to be using velocity. And if I press play, we can see that this works, and we are getting a pretty good result as it is. But what I prefer to do in this case, to control the way we are sourcing this velocity field a little bit better, we are going to use as operation pool. And when we are sourcing in vector fields, we need to turn on the direction strength as well. And for acceleration strength, this will be how fast we blend in the velocities over time. So a value of 10 here was fine in my case. So if I press play, now our smoke will start a little bit slower and gain speed over time. And the smoke is currently dissipating too fast. So what I will do is go to the fields tab, and we will turn off dissipation so the smoke doesn't dissipate at all. And we are just going to adjust the container of this smoke so it doesn't simulate any parts that aren't going to be seen through the camera. So if I go to the bounce here, we can turn on the limit size, and now I can press enter in my viewport, and we can fit this box to the areas that we need. So let's expand this over here, and maybe we can go back to our ground geometry and preview this boolean. Let's go back to our Pyro Solver, and we can now see where we need this container to be. So let's just scale these. And we can also go in the boundary conditions, and we can set this street Y as closed below. So this will create an invisible ground that has a height of 0, which will get rid of any smoke that is below 0 essentially, and it will also collide with this invisible ground. So we don't have to worry about this portion here, because this thing here will take care of it. And let's maybe just squeeze this box a little bit tighter so it's just around our geometry, and something like this will be fine, I think. Let's go ahead and simulate. All right, so we are on the right way. It's just that our smoke is moving way too slow basically. So let's play this in real time. All right, so this is good, but it's just too slow. So what we can do is go to our sourcing tab, and we can increase the source scale, and then we also need to increase the direction strength by the same value. So I will just right click, copy parameter, and paste relative references here. So let's try a double value of 2. And let's press play. Okay, so this is looking much better now, or rather feels better. Okay, and I think we need an even higher value if I'm gonna be honest. So let's use a source scale of 3. And we can also bring in some microsolvers here. So I want to break up this smoke even more. Let's go to the shape tab, and we will turn on disturbance. And let's increase this to maybe a value of 5. And this is looking for the density, which is fine. And for the turbulence, let's also turn this on. And for this, we don't have this temperature field. So let's map this to the density instead. Otherwise, this doesn't work. So now we can decrease the swirl size and also the turbulence. And we will just add some more smaller swirls with this one. And let's simulate again for a few frames. All right, so now we are on the way. Now, a lot of these values here really do come to personal preferences, or if you are working with a certain reference that you have to match. So you will have to play around with all of these settings in order to get what you're looking for. But I think for the most part, something like this will be okay. We are lacking a little bit of volume over here, but if I look through the camera, I don't think this will be too bad. We end up with this result, which I think works pretty all right. But what I'm actually gonna do, I'm gonna go back to our transform here and just reposition this a little bit to account for this direction. So I'm just going to scale this a bit, or rather make it wider. All right, so we are on the way, and the final ingredient here is going to be also adding the collision of our actual snow and also the hand geometry, just to make this whole simulation a little bit more accurate. And from the initial test that I did, I found that adding this collision geometry really did make a difference in the overall result. So let's take care of the collision next.